Okay. Good morning. Crash course. So I do want volunteers. So you can go ahead if you think you understood it pretty well. Real quick. This is in general. I'm going to do this a little bit out of order. Can somebody tell me what does the value of H do? Anybody want to volunteer, or should I cold call?
It makes it go left or right.
Exactly. So whatever you're adding or subtracting in the absolute values, make sure that it goes left or right. So it always goes the opposite of that. So for instance, if I had something like the absolute value of x minus 5, this would be right 5. The quick explanation is because it's what value of x makes this equal 0. So the value of x that would make this 0 would be positive 5, and that's why it's really the opposite, okay? Now, what does the k do always?
Up or down?
Up or down. Now, a is a little bit different, so the k, this is always going to move it up or down. The a, well, how do I know if my entire graph opens up or opens down? So it opens up if what?
A is positive.
A is positive. So if it's positive, if positive, it has to open up. So if it's negative, then that means it has to open down. And how do I know about a stretch or a shrink?
If it's greater than 1 or like a fraction.
Right. So in general, and this is how it's written, if the absolute value of A, so if whatever this is, the absolute value of A is greater than 1, it's a stretch. If the absolute value of A is less than 1, it's a shrink. Now, I told you guys I didn't want to introduce it this way, but now you understand what I'm saying. So A is always what's being multiplied by the absolute value. So positive or negative just tells me how it opens up or down. Then if the absolute value of A is greater than 1, it stretches it. If it's less than 1, it shrinks it. And that's it, okay? Now that's the heart of this. So if you understood that, for the most part, you are good. It's a 95% win. Today, we're going to try and iron the rest of this stuff out. So today's lesson should not be, we shouldn't be on here doing this lesson more than about 15 minutes. So it is literally 3 slides long. We are going to talk more about generalities. So the first thing that I want you guys to see is what your homework kind of looks like. The first part of your homework. So given the graph of the function y equals f of x, this is my function. Write the correct equation of the transformation. We're talking about generalities here and what's going on. Don't make this more difficult than it is.
I have a question.
Yes.
I think, well, on our homework yesterday, we had to show like the transformation when it was on a graph from G to F or something like that.
F to G, yeah.
Yeah, I didn't really understand that. So yeah, I had a question about that.
Okay, so I think you're specifically talking about 1, 2, 3, 4, about like number 5 and 6. I think it was. So I'll try and address that here again in 1 second. In fact, maybe this will do this. Now, the difference between yesterday's assignment and today's assignment is yesterday, they would have given you the equation for this graph and then asked about the transformation. Here, notice I didn't give you the equation. I said y equals f of x. So all I want you guys to do today, and I'll go back and hit this more specifically in just a second, is to look at this in generalities. So if this is my original function, this one right here, look at number one. Well, how is this transformed or changed from the original function to this one right here? Well, what's changed? How has it moved? Up, down, left, or right?
Left.
It's moved left. Has my a value changed at all?
No.
So real quick, Gabe, if this top one is y equals f of x, and this looks like this moved just left 4, does moving left to right affect the x value or the y value?
X.
It affects the x value. So we have two options here. And I know that this is weird, and this is what I'm talking about. So my option is either going to be A. So, and if it's left, would it be +4 or -4?
+4.
So my option would either be this or B. Now, which one do you think it is? Remember, this is my original function. And if I'm just trying to say that it moved left 4, which one, and you guys can have a quick discussion if we need to, but which one looks like the right answer? Which one of these would move it left 4?
A.
A.
Now, somebody that just said that, why would you say A?
Because if
the,
it's You can
Gabe,
go
I already
ahead.
heard from you real quick. So Raylan, go ahead.
oh, okay. In the example for B, it's outside, so it either move up or down. But when it's next to the X, it moves left or right.
That's exactly right. And that's all we're trying to get this point made here on this. So I could give you the exact equation, which I'll do here in just a second, but I want you to think about this in generalities. So if it's affecting the X directly, it has to move it left and right. This, it's just really affecting what your Y value is, so this would move it up or down, okay? Now, let's do this specifically, which is what you would have done last night. The equation for this, my A value looks like it is just up 1 over 1. It opens up, so it's +1, and my vertex is at -3, 0. I'm gonna do this so we're quick. So my original equation was just that. So how would I go from this to this if I mapped this on the same graph? What would I do? Well, if I moved it left 4, I really would have done this. So my new equation would have been right there. Does that make sense? So notice the difference between the generalities and the specific. So on number 2, real quick, we're going back to in general. So my equation is y equals f of x. So the only thing that's happened here is it moved what?
Up.
Up 2. So because it moved up 2, it's going to be the exact same function up 2. Okay. Now, one other thing to be careful about on your homework is look for any sort of stretch or shrink on it. And if it's a stretch or a shrink, if I have something like 2 times f of x, that's going to be your vertical stretch. So that would be more steep. If it's 1/2, that would be your vertical shrink. Now, we don't actually talk about this in this class. We talk about it in Pre-Cal X. But if I had this, now you're talking about horizontal shrinks, not even stretches, horizontal shrinks, which will be explained next year. But that's actually not a standard right now, but just to show you guys. So you can figure that one out by process of elimination. Next one. So this is one that I really want you to pay attention to. So our book only has 3 problems, and I don't even think they're 3 good problems. So make sure that you understand what in the world it's even talking about. So now, if I give you a generic function, for instance, on number 1, there's your function. That's a parent function. And I want you to translate it 4 units left, followed by a vertical shrink by a factor of 1/2. Be very, very, very careful. You have to do it one thing at a time. Now, one thing that I understand I did not explain very well, because I'm going to go over it again today, is what a stretch or a shrink does. From the parent function, it multiplies every single one of those outputs by the factor. That's what it does, every single one of them. So it's not always as simple as just putting, so right here, a lot of people would think, oh, okay, well, 4 up is just going to be this plus 4 and a shrink factor 1/2. Now, that's not exactly right. The order matters. So let me go through and explain this and make sure you watch. You have to do it one step at a time. Well, the very first thing it says, my apologies, is that I have a translation 4 up. And again, that's not really going to affect it, whether it's a linear equation or absolute value, doesn't really matter. But because it is followed by, after I've done that, now it is followed by. That means after I moved it 4 up, now I'm applying a shrink by a factor of 1/2. Which means I take this entire quantity and I multiply the entire quantity by the factor. So my answer is, and it said write a g function, I wrote it as f, I have a bad habit of doing that, is 1/2 x plus 2. So it goes to everything. Any questions?
Do we leave it like the first time you wrote it, or do we have to like
Simplify
multiply
it.
it out?
Yeah, I would
Okay.
like you to multiply it out. Now, and here's the reason I want you to multiply it out. It all doesn't seem like a big deal, and this is still technically right. But here's why. Because I want you guys to be very careful, again, and make sure you understand what you're doing. What if my original problem said this instead of just a linear function? It's really the same thing. So 4 units up, so that's going to be on the outside. You guys have shown me, demonstrated that you understand what that means. Now, if it's still a vertical shrink by a factor of 1/2, I would still take the entire thing and multiply it by 1/2, but you cannot distribute inside an absolute value. That's where we get the a value. So that's your new function, okay? And part of the reason I want to make sure you simplify is I just want to make sure you're not making any silly mistakes by multiplying it in here. For instance, if I had this 1/2 times the absolute value of, if I had something like this, I cannot distribute that inside, okay? So my entire answer would still stay like this. Does that make sense? That's part of why I want to make sure that you simplify it, just to make sure you're simplifying it correctly. Okay. The last part can get kind of confusing. So again, I want to make sure that you guys are paying attention to this. Now, I'm going to follow it up. I realize this is the second or third time I've already said this today, but I don't love these first 2 sections. After this, I think the book gets a whole lot better at explaining a better problem set. So some of this, if you don't get it on the homework, I understand the way they word things, it's really confusing, but order matters. So the very first thing it says, a reflection in the y-axis. Well, reflection in the y-axis, is that going to be this? Or is it going to be this? Which one, A or B? Which one is a reflection in the y-axis?
A.
B.
Ooh, wait a minute. So if it's negative out front, what does that do?
Over the x-axis.
Yeah, so A flips it upside down. That's a reflection over the x-axis. B, if the opposite is inside, that's a reflection over the y-axis, which essentially kind of just flips it around, okay? Now, again, I'm going to show you this a couple times, so you have to do it one at a time. So that's the very first step. The next one, now, once it's reflected, now followed by a translation to the right. So I've just reflected it. Now I need the translation. So 2 to the right would be -2. When I tell you that order matters, I want you to be extremely careful. If I flip this and I said, I want you to move it 2 to the right and then reflect it, it's going to be completely different. If I moved it 2 to the right, here's what I have. And now if I were to reflect this, what that's really doing is taking the opposite of the entire quantity. It's making that whole value negative. That would be your answer. By the way, this is in general. There are some little parts of this that I need to think about just a little bit to make sure absolutely everything I told you is 100% correct. So I just had a what if moment, but I'll think about that here in just a second. If I need to correct anything or change anything, I'll come back. But the order definitely matters. All right. Now, one last time, and this is really just trying to hit this point home. So reminder, a vertical stretch or shrink, it multiplies each output by its factor. So for instance, I know that this moves it right 3 and down 5. You know already how to do this. So right 3, 1, 2, 3, down 5, and my A value is +1. So that's kind of what my original drawing looks like. I already know that. You guys know this. But I'm going to show you what really happens. And I'll change colors here. So let's just pretend like we completely forgot how to graph this. So I'm going to say like -3, 0, 3, and 5. So my original drawing, I'm just going to go through and make the points for my original drawing. So my original drawing, I'm just putting this up here. So when x is -3, I get -3 minus 3, which is -6. Absolute value is 6, minus 5 is 1. If x is 0, I got 3 minus 5, it's -2. I've got 3, it's -2. Oh, I'm sorry. If I've got 3, it's 0, it's -5. And if I've got 5, it is -3. Okay? So essentially all that you're doing, I'll change it to red. If I'm stretching this by a factor of 2, all I'm doing is multiplying each of these by 2. So 2 times 1 is 2, -4, -10, -6. So while that was the original, this is what it looks like. So each one of those points are stretched. So some people are saying, I don't get it. I thought I just moved it and then I stretch it. If you ever have a transformation already from the parent function and then you are stretching or shrinking it, again, we're only talking about vertical stretch. There are horizontal stretches, which we don't discuss until pre-cal. But the vertical stretch, you are multiplying everything by the factor. Remember, you don't distribute inside the absolute values. But that's why this becomes minus 10 and doesn't just stay minus 5. If we were looking at the vertex, my vertex would now be positive 3, negative 10, and that's it, okay? So make sure that you guys don't make any simple mistakes. Any questions? All right. Now, finally, I gave you guys a little bit of free time in here. We don't get out for almost 20 more minutes. So here's what I want you guys to do. You have an assignment. I understand that there's only, let's see, that is 13 questions. You've got 13 questions. I don't think this is overly difficult. So it's already up and assigned in big ideas. But I want to make sure that I don't ding you guys too much on your grade right now, that you have a chance to ask questions. My help session, I want to clear this up too. My help session is going to be tonight after school from 2:45 until 3:15. Hopefully you use this time and you don't really even need that help session. If you ever need help, don't email me on Canvas, email my school email, because that dings and that lets me know you've got a question. I can either answer it right here on my phone, or I can sit here and send you a Zoom link. If you email my Canvas, I have to go into Canvas and check all the time. So make sure that if you need help, email my school account, okay? What I want you guys to do in this last 20 minutes, 18 minutes of class, is to go ahead and start your assignment, hopefully finish your assignment while I stay on here to help you, okay? I'm gonna go ahead and stop recording.